You know, we're always talking about how we need more renewable energy sources, right? Well, the sun and winds are great, but they're not always there when you need them.
That's exactly the problem that Form Energy is trying to
And
solve.
they're doing it with rust.
Yeah.
Rust. Today, we're going deep on their iron-air battery breakthrough, and we're getting all our info straight from this article, The Rust Revolution, Inside Form Energy's iron-air battery breakthrough.
It's really cool what they're doing. Like, rust is usually something you want to avoid,
Right.
but they're actually using the chemistry of rust to store energy.
Okay, so I get that wind and solar need, like, backup power when the weather isn't cooperating, but what's wrong with the batteries we already have? Like, why can't we just use those?
The lithium-ion batteries, those are the kind in our phones and electric cars. They're great for what they do,
Right.
but for the power grid, they just cost way too much, and they don't hold enough energy for those long stretches where maybe the wind's not blowing for days or it's cloudy for a whole week.
The article actually says we need something that's 10 times cheaper than lithium ion to make this actually work on a large scale, which
That's a huge gap to close.
is even possible, yeah.
That's the gap that Form Energy is aiming for. Their whole approach is based on harnessing a super simple chemical reaction: iron rusting in the air.
Wait, so the secret sauce is literally rust. How does that even work? Like,
Think back to high school chemistry. Remember, iron plus oxygen equals iron oxide, which is really just a fancy way of saying rust.
okay, yeah.
So that reaction actually releases energy naturally. And what Form Energy has figured out is how to capture that energy. And on top of that, how to reverse the whole process
Right.
by using electricity to turn the rust back into iron and oxygen. You're basically unrusting it.
Oh, okay, so you're creating this rechargeable rust cycle.
Exactly.
But isn't rust kind of messy? I mean, how do you make that practical for a battery?
Well, that's where the engineering comes in, and it's pretty ingenious.
I was reading about that in the article. They were talking about a special iron electrode and an air-breathing system, which sounds pretty high-tech for rust.
Let's break those down because they're both super important for how the battery performs. So first, the iron electrode. Imagine a sponge,
Okay.
but on a microscopic level,
Right.
with tons of tiny little pores. They basically engineered these iron particles to have a massive surface area, which makes the rusting and unrusting reactions happen way faster.
So it's like a super efficient rust sponge.
Exactly.
But does that mean it wears out really quickly?
Actually, no. These iron particles are actually incredibly durable, and they're designed to go through thousands of charge cycles without falling apart.
So lots of rusting and unrusting.
Lots of rusting and unrusting.
That's amazing. Okay, so then what about this air-breathing system? What does that do?
Think of it like the lungs of the battery. It has to manage a ton of airflow, making sure that the iron has enough oxygen to rust when the battery is discharging, and it controls the humidity to keep everything working properly. Plus, it filters out any contaminants from the air and makes sure the pressure inside the battery stays at the right level.
So they basically built a whole mini atmosphere inside this battery for the rust reaction to happen in.
It's pretty wild, yeah.
That's incredible. It really shows you how much complicated engineering went into this, huh?
It really does. It's not just chemistry. It's all these tiny little engineering problems they had to solve to make it work.
So we've got the basic idea of how it works now, but the real question is, how well does this thing perform? Does it live up to all the hype?
That's what everyone wants to know.
Give me the numbers. How does this iron-air battery stack up against the old-school lithium-ion batteries?
Let's start with energy density, which tells you how much energy you can pack into a given size. Now, iron air doesn't have as high of a density as lithium ion.
Oh, so it might take up more space to store the same amount of power.
That's right. But here's the thing. For the power grid, size isn't always the biggest concern. These installations are huge anyway, so a little extra space might not be a big deal, especially if it saves you a ton of money.
Which brings us to the cost, because the article mentions Form Energy is trying to hit a target of just $20 per kilowatt hour once they get to scale. And that's dirt cheap compared to the hundreds of dollars per kilowatt hour for lithium ion.
It is. That cost difference is what makes this such a game changer. It's like comparing, a used bike to a luxury car.
Exactly, yeah.
No wonder everyone's so excited about this technology. It could make renewable energy storage actually affordable.
Okay, so lower cost. Got it. But what about the lifespan? How long can these rust batteries actually keep running?
Form Energy is saying they're expecting at least 20 years.
Wow.
At least 20 years of life for these batteries.
That's fewer replacements. And less maintenance, too.
Exactly.
Okay, what about duration, though? How long can they actually discharge the stored energy? Because we're talking about covering those times when there's no wind or sun for days on end.
That's where iron air really shines. They're designed to last for 100 hours or more, meaning they can just keep going for days.
Ah,
And that makes them perfect for those long stretches of low renewable energy production.
okay, so we've got cheaper, longer lasting, and they can cover those multi-day gaps.
Yeah.
What's the catch? There's got to be a downside somewhere, right?
Well, there are always trade-offs with anything.
Right.
So as we said, the energy density might be a bit lower than lithium ion, but that may not be a deal breaker for the power grid. Another thing is round trip efficiency, which is basically how much of the energy you put into the battery you can actually get back out.
So you lose some energy in the process.
Yeah. Iron air currently has a round trip efficiency of about 50%, so you lose roughly half of the energy.
That sounds like a lot.
It is, but lithium ion batteries lose energy too, just not as much. The key is to weigh that against the lower cost and longer lifespan of iron air, and in many cases, iron air comes out ahead.
So it's all about picking the right tool for the job, right?
That's right.
And for large-scale grid storage, it sounds like iron air might be the perfect fit.
It could be.
And if it all works out the way everyone's hoping, this could really change how we use renewable energy.
Absolutely. Imagine a world where most of our energy comes from the sun and the wind, backed up by these really affordable, long-lasting iron air batteries.
And even when the weather isn't cooperating, everything just keeps running.
That's the vision?
It's a pretty compelling vision for a cleaner and more sustainable future, for sure. It's making me really optimistic about this whole Rust revolution. But like with any new technology, there are still some unanswered questions and some challenges to overcome. I'm curious to know more about how they perform in real-world situations. Like, how do you actually integrate these batteries into the existing power grid? And what about their environmental impact over their entire lifespan? Like, is it truly as green as it sounds?
Those are all good questions that we'll have to keep in mind as this technology continues to develop. It's going to be fascinating to see how this all plays out.
Let's take a step back for a second and think bigger picture here. If this iron air technology gets as big as everyone's predicting, what could it mean for other industries besides just the power grid?
That's a really good question.
Could we see these in our homes or businesses or even electric vehicles? Or are those limitations we talked about, like the lower energy density, going to make that impossible?
We'll have to save that question for another time.
I'm already thinking about it.
But it's definitely something to think about.
It is. And for our listeners out there, I'm going to leave you with this thought. If this tech really does take off and becomes the main way we store energy, what other industries could this change completely? What new possibilities could it unlock? It's a conversation we need to be having.
Absolutely. Yeah, it really does make you think, huh? But before we go too far down that road, let's get back to those real-world questions you were asking about.
Right, because it's one thing to have a cool idea, but it's another to prove that it actually works out in the real world, right?
Exactly. Form Energy is already doing some pilot projects with utility companies, so we're starting to get a sense of how these batteries perform outside the lab.
That makes sense. I mean, building the battery is one thing, but making sure it can actually talk to the grid and handle changes in supply and demand, that's a whole other challenge, right?
Yeah, exactly. And so far, it's looking good. It seems like the batteries are integrating pretty smoothly, responding to signals from the grid quickly, and doing a good job of evening out those fluctuations in renewable energy supply.
That's great news. Now, what about the environmental impact? Because I know they're using iron, which seems pretty harmless.
Right.
But are there any downsides to this technology that we need to be thinking about?
That's a really important point. I mean, no technology is ever completely without some kind of environmental impact, and iron air batteries are no exception. One thing to consider is the mining of the iron ore, which can have consequences if it's not done responsibly.
Right, so making sure the materials are sourced sustainably is super important.
For sure.
What about the batteries themselves? Can they be recycled? Like, what happens when they reach the end of their lifespan after those 20 years?
Those are all questions that Form Energy is working on. They're designing the batteries to be recyclable from the start, with the goal of recovering as much of the materials as possible when they're no longer usable. Plus, they're looking for ways to minimize waste during manufacturing.
Sounds like they're really thinking ahead, considering the whole life cycle of the battery, from the materials to the end of its life. That's great to see.
Yeah, I agree. It's not just about building a better battery, it's about building a better system in general. And that includes being aware of those environmental impacts and making sure that everything is sourced and recycled responsibly.
Okay, so we've covered a lot of ground here. We talked about the chemistry of rust, the crazy engineering behind this battery, and what it could mean for the power grid. And we even touched on what it could mean for other industries, too. I feel like we're just scratching the surface here, though.
I think we are.
There's just so much potential with this technology. It's kind of mind-blowing.
Yeah, I agree. It feels like we're at the very beginning of this whole iron air battery revolution.
And it makes you excited to see where it goes from here, right?
Oh, definitely. But for now, I think we've given everyone plenty to think about.
Yeah, we have. So to recap, Form Energy's iron air battery is looking like it could be a total game changer when it comes to storing renewable energy. It's cheaper and lasts way longer than the lithium-ion batteries we use now, and it's perfect for dealing with those long gaps when there's no wind or sun. And even though we still have some questions about how it'll work in the real world and what the long-term environmental impact might be, the initial results are looking really good. It could seriously change how we power our world.
No doubt about it.
And like we were talking about, the impact of this could reach way beyond just the power grid and maybe even shake things up in other industries too.
That's right.
It's kind of like opening a door to a whole new era of energy. And it's not just about ditching fossil fuels for renewables. It's about coming up with a whole new way of generating, storing, and using energy.
It's about building an energy system that's more resilient, more sustainable, and works for everyone. And this iron air battery could be a big part of making that happen.
I'm definitely going to be keeping a close eye on how this develops. And for our listeners out there, I hope you'll do the same. Keep your ears open for any news about Form Energy and these iron air batteries. This is one revolution you don't want to miss.
And if you're feeling inspired after this deep dive, don't stop here. There's a whole world of information out there about renewable energy and how we're going to power the future. So go explore, ask questions, and share your thoughts with everyone. The more we all learn and talk about these issues, the better prepared we'll be for the future.
It really is exciting stuff. It makes you think about all those rusty things we see all the time in a whole new way. I mean, who knew rust could be the key to a whole new energy system?
Right. Sometimes the biggest breakthroughs come from the most unexpected places. You just have to look at things with fresh eyes.
Yeah, it makes you wonder what other possibilities we're missing. What other resources or reactions are just sitting there waiting for someone to figure out how to use them?
That's what I love about science. There's always something new to discover and new problems to solve.
It feels like we're on the verge of a totally new energy era. And it's not just about switching from fossil fuels to renewables, it's about changing the entire way we think about energy, how we create it, how we store it, how we get it to people. It's a huge shift.
Absolutely. It's about creating a better system for everyone, a system that's more reliable, more sustainable, and fairer. And this iron battery could be a big part of that.
I'm definitely going to be watching this closely. And for everyone listening, I hope you will too. Keep an eye out for news about Form Energy and these iron air batteries. You don't want to miss out on this.
And if you're feeling inspired by all this, don't let the learning stop here. There's a ton of information out there about renewable energy and what the future of energy might look like.
Go out there and explore, ask questions, and share what you learn. The more we all talk about these things and understand them, the better prepared we'll be for whatever comes next. Thanks for joining us for this deep dive.